This series is part of my own journey to understand how the universe began. It isn't taken from any formal study material. It is simply my exploration, my attempt to make sense of the cosmos using publicly available scientific knowledge. Let's start the journey. Before the universe began, there was no time, no space, no matter, no energy. Not even darkness, because darkness requires space for light to be absent. According to NASA's cosmology division, the concept of before the Big Bang loses meaning because time itself had not yet emerged. Existed was an emptiness. It was something far stranger, a quantum vacuum. A state governed not by classical physics, but by quantum mechanics. CERN explains that even in a perfect vacuum, quantum fields never reach zero. They fluctuate, creating tiny bursts of energy that appear and disappear. These fluctuations are not particles. They are possibilities, temporary ripples in the quantum field. In this primordial realm, the idea of before becomes meaningless. There was no ticking clock, no unfolding sequence, no past or future. Time, the very thing that gives structure to our thoughts, memories, and existence, simply did not exist. According to NASA's cosmology division, time is not an external backdrop. It is a property of the universe itself, emerging only when space and energy come into being. So when we ask, what happened before the universe? We are asking a question that nature itself does not recognize. Imagine standing at the edge of time, a boundary where the concept of earlier has no meaning. This is the frontier the early universe presents to us. Not a wall, not a barrier, but a point where time simply stops. According to the Hawking-Hartle no-boundary proposal, the universe didn't begin at a single point in time. Instead, time gradually emerged from a timeless state, the way a sphere has no edge. In this view, the universe has no sharp beginning, only a smooth transition from timelessness into time. 2. In our everyday world, everything follows a sequence, one moment after another. But in the pre-universe state, there was no sequence at all. No first, no next, no unfolding story. According to theoretical physics research from the Max Planck Institute, the earliest state of the universe was governed by quantum rules, where classical time does not apply. This was a realm where events did not happen in order, because order itself had not yet been born. And then, in a way we still struggle to fully understand, time switched on. Not with a bang, not with an explosion, but with a transformation, a shift from timeless potential to unfolding reality. According to the Hawking-Hartle model, the universe transitioned from a state with no time dimension into one where time behaves like the axis of a cone, gradually becoming the time we experience today. In that instant, the universe gained direction. Moments could now follow one another. The cosmic story could finally begin. To make this more intuitive, imagine a perfectly calm ocean. On the surface, it appears still. But deep below, currents swirl with hidden energy. As physicist Brian Greene describes, the quantum vacuum is similar, seemingly empty, yet full of motion beneath the surface. The early universe was not absolute nothingness. It was a field full of potential. And then, something extraordinary happened. One quantum fluctuation didn't fade away. Instead, it triggered a runaway expansion of space itself. According to MIT physicist Guth, this event is known as cosmic inflation, a rapid expansion driven by quantum fluctuations. This was not an explosion. It was a transformation. The moment potential became reality. The universe emerged, not from absolute nothingness, but from a state where the laws of physics already existed in some form. ESA's Planck Mission data supports this idea, showing patterns in the cosmic microwave background that match predictions of inflation. In this moment, the universe took its first step toward becoming everything we know. As the universe transitioned from pure potential to reality, something remarkable emerged. Space-time itself. Not space. Not time. But a unified fabric that would shape everything that followed. According to NASA's Universe 101 Cosmology Guide, space-time is not a passive stage. It is dynamic, stretching, and curving in response to energy. In this first moment, the universe gained structure, a framework upon which galaxies, stars, and life would someday form. In less than a trillionth of a second, the universe expanded unimaginably fast. This was the era of inflation, a moment when the cosmos grew from smaller than an atom to larger than a galaxy. MIT physicist Alan Guth, who proposed inflation, describes this expansion as exponential growth, driven by vacuum energy. This expansion smoothed out the universe, setting the stage for everything that would come next. As the universe expanded, it cooled. And as it cooled, the fundamental forces of nature began to separate gravity, electromagnetism, and the nuclear forces. According to CERN's particle physics research, these forces were once unified in the earliest moments of the universe. This separation created the rules that govern reality, the laws of physics as we know them. As the universe cooled further, energy condensed into matter. Tiny particles, quarks, electrons, neutrinos began to form, according to the ESA Planck Mission. This transition from pure energy to matter occurred within the first microseconds of cosmic history. Most matter and antimatter destroyed each other, but a tiny imbalance allowed some matter to survive. And that small leftover fraction became everything: stars, planets, galaxies, and eventually, us, the earliest light. The cosmic microwave background still carries the imprint of these first moments. NASA's WMAP and ESA Planck satellite mapped this ancient light, revealing tiny temperature variations that acted as seeds for galaxies. In these faint patterns, we see the blueprint of the universe. References and scientific sources: NASA Cosmology and Universe 101. NASA WMAP, Mission, CERN. Quantum Vacuum and QFT. Max Planck Institute for Astrophysics, Alan Guth. Inflation Theory, Linde. Chaotic Inflation. Hawking and Hartle. No Boundary Proposal. ESA Planck Mission, Brian Greene. The Fabric of the Cosmos, Sean Carroll. From Eternity to Here. Thank you for watching and being part of this journey. Your curiosity is what keeps this exploration alive. Subscribe for Part 2, the first instant after creation.